Hello everyone, I am Sayantani. Welcome to my class. Welcome to another video of Let's Learn Geography channel. Today I am continuing the plate tectonic theory. I already have uploaded the plate tectonic theory part 1. If you have not watched this video, just go and watch this. That it will be benefit for you to understand this class. And if you have not joined our telegram channel, so join there. You can get the notification of the latest video as well as also get the PDFs of your related subject. So let's start the next part of plate tectonic theory. Before going to discuss about the type of plate tectonic theory or going to discuss about the plate margin and plate boundary, we just recap our previous class where I have discussed about the plate tectonic theory, which was the great achievement of 1960s decade. Also, it was based on the two major concepts, that is continental drift theory and seafloor spreading, and also discussed the concept of plate, that is the rigid lithospheric slab tectonically called the plates, and their plates movement, how plates are moved, what are the natures of the plate that are moved, what are the major plates, minor plates, who have gave the first concept the plate, that is J.T. Wilson in 1965 have gave about the term plate. Also there are so many geologists and geophysicists like Mackenzie Parker, J.W. Morgan, Lee Pichot, who had contributed about to the concept of plate tectonic theory. And also we have discussed nature of the plates and the main features of the plate. There are the two type of plates, that is the continental crust and the oceanic crust, and they are dynamic in nature. And some major plates are Eurasian plate, Arabian plate, North American plate, South American plate, Antarctic plate, Pacific plates, and an Indo-Australian plate. And there are some minor plates and major plates are there. Some medium plates are like Arabian plate, Nazca plate, Juan de Fuca, Cocos, Philippines, Caribbean, Indian, Croatia. These are the all medium type of plates, and there are 20 minor plates, and Panama, Somali, and etc. And there I also discussed about the causes of plate tectonic, the gravitational force, conventional current, upwelling of magma. Those are the causes, main factors for the plate tectonic theory. Now we are focusing on our today's topic, that is the plate margin and different types of plate boundaries. Before going to discuss about the different types of plate boundaries in details, first of all, we should know about the two concepts, that is the plate margins and the plate boundaries, because these two are the very important concept. All tectonical activity along the plate margins occurs there, that is the seismic event, volcanism, mountain building, faulting, falling, all kind of tectonical activity occurs along the plate margins and plate boundary. That's why both concepts are very important and both has a significant role in the plate tectonic theory. What is plate margin? Plate margin is when marginal point, if that is the plate boundary, if it is a plate, the marginal point is called the plate margin, and the plate boundary lies between two plates, or I can say that it is the surface stress zone of motions. Basically, there are three types of plate margin: constructive, destructive, and transform boundary. In this picture, I try to explain the three concepts in one picture. If you see that fringe formed in the convergent boundary, because why? Convergent boundary is when two plates moves towards each other. Divergent boundary is when two plates moves apart from each other, or I can say they move in the opposite direction. And third one is transform boundary, they just passes each other. Next slide I will discuss it in details. But three concept is convergence is when they move towards each other, divergence is when they move moves in opposite direction, and transform boundaries they just passes each other. Divergent boundary, when two plate it moves in the opposite direction and hot molten magma moves upward and they deposited there. After solidifying and cooling down this, they form the new oceanic crust. That is the plate boundary. So another name of plate boundary is constructive boundary, accreting boundary. Why constructive boundary? Because continuous upwelling of magma, because two plates moves in the opposite direction. Two plates moves in the opposite direction. And asthenosphere, the magma try to move upward, and the magma deposited in the seabeds, and after cooling and solidifying of magma, the new oceanic crust formed, and this process is continuously going on, and the new oceanic crust the formation of new oceanic crust is going on. That's why this is seafloor spreading formed. There is continuous upwelling of magma and molten material. New oceanic crust formed due to the upwelling of magma, and due to the movement of opposite direction, the two plates split along each other and the mid-oceanic ridge formed. And the divergent movements of plates result in the seismic event, volcanic activities, oceanic crust, transform fault, and drifting of plates occur. Next one is landform, that the formation of land on the plate divergent boundary. In this picture, how the mid-Atlantic ridge is formed. Mid-Atlantic ridge is, for the shape of mid-Atlantic ridge is S, and how this mid-Atlantic ridge formed due to the movement of North American plates and the South American plates. The mid-Atlantic oceanic ridge formed. Basically, a range of submarine mountain and volcanoes are there in the mid-Atlantic ridge. When the North American plate moves in the westward and the Eurasian plates moves in the eastward directions, and due to the movement of opposite direction, there is a continuous upwelling of magma, and they deposited on the seabed, and this process is continuously going on, and the mid-oceanic ridge formed. And when two plates split apart to each other, that time the mid-Atlantic ridge formed. And the best example is North American Eurasian plate, movement of North American Eurasian plates. Next one is the HORST and GRABEN. Divergent boundary also developed on the land also. Not only in ocean, there is also developed on land. When these happen, that time the HORST and GRABEN formed. HORST and GRABEN, these are referred to the tropical topography that created when earth crust pulled apart. When two plates moves in the opposite directions, due to the extension can stretch crust up to 100% of its original size, and any crust strained in this way, normal fault developed, and the block of this crust either drop down or moves upward. That time when the land moves downward, that time GRABEN is formed. When the land moves upward, it is called the HORST. So due to the divergent boundary, HORST and GRABEN also formed. Next one is fault block mountain. When the divergent movement of motions occurs beneath the continental crust, rift structure and the normal fault formed generally. This continental rift causes of the valley floor to drop down along the fault line. This combination of the drop down basin and adjacent fault block can produce the dramatic range of front. Next one is convergent boundary. Convergent boundary is when two plates, it can be continental crust or the oceanic crust, moves towards each other, and the lighter material moves in the heavier material subducted to the lighter material. This boundary is called the convergent boundary. So definition is here: when two plates move towards each other along a line and collide when the leading ridge of the one plate is relatively form lighter material and another is the heavier material, and the lighter material is lost in the middle. So, and the continental crust and the oceanic crust. As we know, oceanic crust is heavier than continental crust, and oceanic crust, and when they towards each other, oceanic crust moves in downward and continental crust are lost there. This point is lost there. That is called the convergent boundary. Another name of convergent boundary is destructive boundary also. Why destructive? Because the lighter material lost in the mantle. That's why this is called the destructive boundary. And the zone where when the oceanic crust is moves downward and continental crust is there, this is from 45-degree angle, and this is called the subduction zone or the Benioff zone. When the lighter material overrides the heavier material with the 45-degree angle, this is called the subduction zone or the Benioff zone. Sometimes the lighter materials moves downward, or I can say that the heavier material thrusted the lighter material. That time is called the abduction zone. And the lighter material when overrides to the heavier plates result in the volcanic eruption, formation of fold, and earthquake happen. There are three types of convergent zone. Next slide I will discuss the three types of convergent zone with the detail. The type of convergent plate boundary. There are three types of convergent plate boundary. One is oceanic crust collision, another is continental collision, third one is oceanic continental collisions. First I will discuss the oceanic collisions. When two oceanic plates moves towards each other and one is having lighter material, another is having the heavier material, they collide each other, and comparatively which one is heavier, they moves downward at the 45-degree angle, and another lighter materials is move upper overrides there. That is called the oceanic collisions. And such collisions occur due to the volcanism, earthquake are formed there. And typical example of this convergent boundary is oceanic convergent boundary zone is Pacific plates of South Alaska, which creating the Aleutian Island, under the Philippines plate where it's create the Mariana Trench is the deepest part of the ocean. This is the most typical example of ocean collision. Before going to discuss the next topic, I just like to tell you that if you have not subscribed my channel, please subscribe this and share with your friend. And I already have uploaded so many videos on related to geography. If you have not watched this, just go and watch this. And next concept is continental ocean collisions. So the name suggests that ocean and continental means there is obviously one oceanic crust and another is continental crust. When the continental crust that is having lighter material and another is having the heavier materials collide each other, Then the volcanic eruption, folded mountain, crustal rocks are formed there. Typical example of this: the collisions of the American plates and the Pacific plates. Pacific is the oceanic plates and the American is the continental plates moves towards each other, and the Pacific plates moves downward to American plates, or I can say the American plates overrides the Pacific plates. This is the typical example of ocean and the continental collide. And another example is ocean continental convergent boundary is Nazca Plate under the South America, which create the Andes Mountain and the Peru Trench, and the subduction of the Juan de Fuca plates under the North American plates, that is creating Cascade Trench. That is the most important example of the ocean and the continental collisions. Next one is continental. That is continental. Both are lighter, but which one is and the comparatively heavier continental crust moves downward. Like that, the Eurasian plates and the Indian plates are forming Himalaya. Eurasian plates and the Indian plates both towards each other form the Himalaya. And also the African plate with the Eurasian plate creates a series of Alps in Europe and Zagros mountain in Iran also. Rocky Mountain in North America also the result of the continental collisions. Next one is conservative. Another name of conservative plate margin is transform fault boundary and shear plane margin. There is no volcanic activities and the seismic event occurs because they do not interrupt each other, or I can say they do not collide each other, they just passed each other or slide each other. That's why this plate margin is called the conservative margin. And the most important or famous, I can say, famous example of conservative plate margin is the. Now I am discussing the another important topic, that is triple junction. Throughout the two class, I just discussed about the two plates moves towards each other in opposite direction. They passes each other. But when three plates moves towards each other, they form the triple junction. There are some localities where the three plates are in contact each other. Triple junction between three oceanic ridges such as the South Atlantic between Africa, South America and Antarctica. When the African plates, South American plates and the Antarctic plates moves towards each other, they contact each other, they form the triple junction. There are two types of triple junction: stable triple junction and the unstable triple junction. A similar notations can be used to identify the triple junction is when the oceanic range are indicated by capital T, transform fault are indicated by capital F. For instance, rich trench would be termed as a RRT triple junction. However, some can exist briefly before they evolve into the another plate configurations, that is called the unstable triple. There are 7 types of triple junction exist in the plate margin or plate boundary in our world, that is the RRR, means South Atlantic, Indian Oceans and Galapagos Island in Pacific, that is this region. Next one is Central Japan, where the three trench contact each other. In the coast of Chile, there are 2 trench as well as 1 fault interact each other. TTR, the Morcibel Island or the Western North America is there to interact each other. Junction of San Andreas Fault and the Western USS Fault meet each other. They formed FFR, and last one is the one is ridge, another is trench, and one is fault. They meet each other, they form triple junction. Thank you for watching. If you like this video, just press the like button and share with your friend. And more video like this is similar this is coming soon. In our next class, we'll be discussing the concept of island arc, which is very important topic. And thank you so much. Be positive, be kind. Thank you.